All right, so now in this video, we're going to do probability or our probability review, and this is going to be continuing 4.1 probability PDF that you'll find in module 4. Let me share my screen to the whiteboard. All right, so probability review. So in the last video, we had dimensional analysis. We broke it up into different pieces. So the properties sold in a given year could be a random variable. Meetings that you have with a specific client or a potential client could be a random variable. Advertising views could be a random variable. And then to take it another further, you could have the return on your portfolio could be would be a random variable. So the return on your portfolio, return on a stock, number of customers arriving in your store, the time between the time that it takes in order for the next customer to get to your store. All of those are examples of random variables. And then you also have an event. An event is a specified set of outcomes. So how likely is it that a specific event will happen? So maybe what is, you could say an event could be having returns on your portfolio or portfolio returns greater than 5%. That would be an event. So the definition of a probability. So the definition of a probability, there's two pieces to it. So I'll say one right here. I'm going to say the probability of any event E is a number between 0 and 1. So remember, I'll say between 0 and 1. So the probability of event E is going to be equal to or less than 1 or equal to or greater than 0. So the probability of any event is a number between 0 and 1. And for 2, and again, all this is in the PDF on eCampus. So the sum of the probability of any set of mutually exclusive and exhaustive events equals 1. So this means the probability of all of the events, of all exhaustive events. So this could be as simple as saying probability of event 1 plus the probability of event 2, if we keep it general. But say the probability of it raining plus the probability of not raining would be 100%. It doesn't matter what either one of those are. You can take this further, and we'll take it all the way out to to N many events. And if you add them all up, if you add up all mutually exclusive and exhaustive events, it will equal 1. So mutually exclusive means that only one event can occur at a time. So this would mean that it's either raining or not raining. You either had portfolio returns of greater than 5% or you did not. So those are mutually exclusive. You can't have them both. You could have and then exhaustive means that the events cover all possible outcomes. So that has to be 1. So let's say, let's do an example. Let's say example right here. So let's say you have an event A. Event A is portfolio earns 10% or more. So let's say RP. So returns for the portfolio is equal to or greater than 10%. So 10% or more, equal to or greater than 10%. And let's say we have event B. So this would be everything that's not. It would just be, let's just say portfolio returns less than 10%. So these are mutually exclusive. You can't have a portfolio that earns 12% and 8% at the same time. It can only be one or the other. They both can't take place at the same time. And then this also is exhaustive. So if our portfolio earns say it earns 10%, or our portfolio earns 1,010%, it's still event A because it's 10% or greater. It's exhaustive. This would include all real numbers, all possible outcomes. So in this example, it doesn't matter what the probability of A is. Doesn't matter what the probability of B is. If we add them up, it should be 1 because this is mutually exclusive and it's exhaustive. So in finance, we often estimate the probability of an event as a frequency of occurrence. It's empirical, so it's based on historical data. Then this method would produce an empirical probability. So maybe historical returns, maybe you create a histogram. You use as you do, and you create it, you get a little bit of a distribution of your returns. Maybe what would be empirical? So it'd be a histogram, not a wouldn't be smooth like this. So it'd be a bunch of bars, bars like this. Maybe it wouldn't be so smooth. Whatever it is. So now if you add up historical returns, you could say, you just look at historical returns and you could say, say this right here. And say this is 10%. So this or greater would be event A. So you could just, the probability of A, you could just add up everything that was 10% or greater, divide it by all of the historical returns. Now you have a potential probability for that. Doesn't mean that it is the probability of having 10% or greater, but it would be a way to estimate that. So if so in a narrow range of well-defined problems, you can deduce a probability by reasoning. So you can reason through. So back in our previous video with dimensional analysis, we kind of reasoned through it. Maybe if you were a consultant and you were hired by somebody, maybe they build custom boats, and maybe it takes 6 months to build a boat. Maybe they're large yachts, whatever it is, and it takes time to meet with someone. It's a very specific person who would build a custom built boat. It's a very specific person. You'd have to meet with them. It takes 6 months to do it. You have to meet with them so many times in order to do that, to know what they want, to know how to price it. And then before that, people have to make phone calls. Maybe out of 20 people that call you, only one person is actually serious. So by talking to someone, if you're a consultant, maybe you can estimate what the probability could be, or you can try to follow the process. So now you know more about what you're trying to estimate. And then so that'd be a maybe a prior probability, but being able to estimate that, being able to estimate any of this is what statistics and probability is all about. So so this was our definition of probability. So now for more of our probability review, let's say we have two independent events. So two independent events. Let me clear out some of this. So two independent events, let's say A and B again. Maybe this not the same A and B that we just did, but so say it's A and B. The probability of both A and B happening at the same time. I gotta do some of the notation. I gotta keep clearing all of this up. So let's do a draw. Here we go. All right, so let's say you have events A and B. And let's say you say the probability of A and B. To show this in our notation for probability. So A and B, you're going to do a cap. So it's a union. So it's the probability. This is equal to the probability of A and B. This is the probability of A and B happening at the same time. So this, if we were asked this in the previous example about portfolio returns, this would be 0. You can't have both at the same time because they are mutually exclusive. But this is independent. So this could be maybe it's raining maybe A is it's raining and B is you want ice cream. Those may be completely independent. Or maybe not, but so the probability of A and B is the union. If we say the probability of A or B, this is I'm sorry, this is a cap. This is the union. So now the probability of A or B would be the big U. So this is the union. This is the intercept. I'm sorry, I switched them up. So the probability of A or B. So it could be one or the other. It doesn't matter. This is how you'd write that. And then so the formula for this, the formula for A or B would be equal to the probability of A. Remember, this is only for independent events. The probability of A plus the probability of B minus the probability of A and B. So why do we take it out? Why do we take out the probability of A and B when we're adding these two together? Because if you have, say we have this is A, the event A happening. Let's say this is, that's not very good. Let's say this is event B happening. If we add up all of A, if we add up all of this, the probability of all of A, and then we say add the probability of B, you add this in the middle, the intercept, you add it twice. And you can't do that, so you have to take it out once. So that's why we subtract it. And you'll see that in the probability review, or in the module 4.1 review. So this is probability of A and B, the probability of A or B, and this is the formula for the probability of A or B. So now if we take it a step further, and now we do a conditional probability. So let's say the probability of A given, that's what that line is, given B. So we're wanting to know the probability of A occurring given B has already occurred. B has already happened. So maybe if A was it's raining and B is you crave ice cream, or maybe it's sunny and you crave ice cream. If you crave ice cream, you already crave it. What's the probability that it would be the weather would be whatever it is? So with this would be remember, this is the probability of A given that B has already occurred. In order for that to have happened, this would mean we want the intercept. So the probability of A and B over the probability of B, because remember, B has already occurred. And in this is the divisor. In the denominator, you have the probability of B. This means that the probability of B has to be, it can't be 0 if you can't divide by 0. And then from the conditional probability, so this is conditional probability, conditional probability, we get the multiplication rule. So the multiplication rule, you can, we just multiply both sides by the probability of B, which you get up there. So this would mean that, draw a line here so we don't get confused. So this would mean that the probability of A and B is equal to the probability of A given B, meaning B has already happened, multiplied by the probability of B. So this is the multiplication rule. Multiplication rule. If A and B are independent, only if they're independent, then this would mean that the probability of A and B happening would be equal to the probability of A multiplied by the probability of B. So where this comes from, if they are independent, if they are completely independent, if they're independent, then that would mean the probability of A given B, they're completely independent, then that would just be the probability of A. When two events are not independent, they are dependent. This means the probability of an occurrence is related or dependent on the occurrence of the other. All right, so we have one more thing to talk about with the probability review, and then we'll do some stuff in Python, and that will finish off 4.1 from Module 4. So we're going to talk about the total probability rule. So I'm going to get rid of all of this. So the total probability rule. From the definition of probability, the sum of probability is of any set mutually exclusive and exhaustive events equal 1. So we already talked about that. Maybe this will be faster. So from the probability rules, I think it was earlier in this video, the sum of all mutually exclusive and exhaustive events will equal 1. So that was whenever we had the probability of event E, E1, or event 1 plus the probability of event 2 plus the probability of event 3, and so on all the way to N is going to equal 1 as long as they are all mutually exclusive and exhaustive, so they cover all possible outcomes. So if you were back from stat, if you have a B, so let's say I'm going to draw a box. Let's say all of this is our space of possible things, of possible outcomes. Let's say this is let's do B. Be consistent with the notes. So let's say this right here is event B. Everything that is not event B, we'll say is B complement. We'll say BC. So everything that's not B is going to be over here. If we were to add up, let's say the probability of B plus the probability of everything that B isn't, that would be equal to 1. Take it a step further. Let's say we're trying to estimate the probability of event B. Maybe event B is, maybe it's some kind of default probability, or it's a probability of break even, or it's a probability of some specific event given a contract, or maybe it's defaults, whatever it is. Maybe you can't directly estimate B, but you can estimate what B isn't. So maybe you can't necessarily estimate the probability of a company not going bankrupt, but maybe you can estimate the probability that a company will go bankrupt. So maybe so from that you could if you know the probability of them going bankrupt, then 1 minus that would be probability of not going bankrupt or defaulting. So if you combine all of this, if you take it a step further, if you take it a step further, this isn't really important necessarily for this class, but if you were to take more advanced levels or anything with Bayesian or something like Bayesian econometrics, then it's a little more important. But combining everything up to this point, we would get the total probability rule. So now let's say the probability of A. That's bad penmanship. Let's say the probability of A. That would be, we take it a step further, and let's say that's equal to the probability of A and B. Let's say up here, say this is A. So the probability of A and B happening together, that would be this right here, plus the probability of A intersect with B complement, everything that B isn't. That would be over here. And we'll take it a step further. Now we can say the probability of A is going to be equal to the probability of A given B multiplied by the probability of B plus the probability of A given the probability of B complement multiplied by the probability of B complement. So when it comes to this, the total probability rule and a little bit of Bayes' theorem, we're not going to use a whole lot in this class. Really for this, we're not going to use very much at all, but some of this stuff we covered earlier will be real important going forward. So that finishes this. In the next video, we'll do some of this in Python. We'll go over it. We'll use the TIPS data set, and I'll go over how some of this can be applied.